Hi everyone. So here we'll be starting like we'll be doing a few more questions on binary search, and I'll tell you guys if you're coming from part one, two videos, it will be like cakewalk for you. And the other thing is, these are questions that are type one, so they will not require any hard and such like solutions. They'll be pretty simple. If you have like watched my part one, part two videos, then now let's see the first problem, which is valid perfect square. So what it says? You are given, let's say, a number n, and you have to find you have to say that like tell true if it is like a square, perfect square. If that number is less, not like it's not a square, perfect square, you have to return false. So here if you see 16 is perfect square. Who is square root of 16? 4. So 16 is obviously a perfect square, but for 14 it is like it does not has any perfect like square root. Okay, so its square root will lie between 3 and 4. So obviously 3 square is 9, 4 square is 16. So 14 will 3 point some values, but you wanted whole. Okay, so if you see in brute force, how can you go? How can I think like just think in a way that if you draw a number line 1, 2, 3, 4, 5, 6, 7 to, let's say, to 16. Okay, we can obviously reduce this, but till 16 right now, consider this. So you can start from here. You can start from first value. Just think it on in this way, that 1 cross 1, do in this way, like you iterate from this range, and you're having I value. So what you have to do, you have to do I cross I and check if I cross I is less than equals to k. I cross I less than equals to k, and keep a ans variable and keep on updating. If it is less than equals to k, keep on because you see this. I'll tell guys, no problem. So if you see this, so what happens? 1, then 2 cross 2 is 4, 3 cross 3 is 9, 4 cross 4 is 16. Now see guys, you got this value 4 cross 4, which is 4 cross 4, which is actually 16. Okay, 4 cross 4, which is 16, and that is what you wanted. Okay, now you can like either return, like keep this variable true, or like initialize it with false, and only when you get 4 cross 4, like I cross I equals to k, update this value to true. Otherwise it will be false always, and you can return finally ans. Okay, and for this, let's see, for this 14, what you can think of: I cross I, 1 cross 1, it's not like it's not equal to 14, it's lesser than 14. 2 cross 2, 3 cross 3, so 3 cross 3, which is 9, is lesser than 14, no problem. Now listen guys, 4 cross 4, 4 cross 4 is actually greater than 16, sorry, greater than 14, I mean greater than 14. So till 9, till 3 cross 3, which is like 3, you have not found any perfect like square root for this number, for 9. And once you go past by this, like 3 cross 3, you got 4 value, 4 cross 4 which is actually 16 is greater than 14. Now after 4, all the values are greater than 4. So obviously 5 cross 5, 6 cross 6, so they also will be greater than 14. So in this case you would not update ens variable. So what I can say guys, your favorable range, if you see this clearly, the hint is right away given in the test case itself. Okay, the way you try to solve it. So all the values lesser, like, listen how we'll be writing that condition and everything. All the values starting from, let's say, 1 till your value k or n, whatever you call. Let's keep this k. Okay, all the values starting from 1 to k, you will iterate, and all the value whose mark this variable I, which will be using for iterating from 1 to k. All the values whose square is lesser than equal to k, you can call them favorable. And this is where, because they are lesser than k, so you'll move forward in a way that you think that I can get answer. But once I cross I is greater than k, you will not find that, you cannot find your answer in this zone, which is your unfavorable zone. Are you getting it? Are you getting it, guys? So I cross I so now let's see what I said: 1, 2, 3, 4, 5, and let's say for 16 I'm saying, sorry. So you see, what I said, I cross I is lesser, than equals to k. This zone will be favorable. So for this, for 16, which are favorables? If you see, all these are favorables, and once I cross I becomes greater than k, Who's unfavorable? All these are unfavorable. Rest all are unfavorables. Now listen, who can give your answer? Here if you see, the last the last value of first space, which is a favorable. And if you remember guys, your binary search part 2 video, L and H, if they start here, where L will be at the first value of the second space, H will be at last value of the first space. So H will give your answer. H will give your answer. But hold on to this point. Let's see for that example as well. So that is one thing guys. For me, I never directly go and write code until and unless I handle edge cases. I handle all sort of cases. So let's see for 4 as well. If I write this 1 2 3 4 5 6 blah 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 and 14. So as I said, till the point I cross I is lesser than k, if than equal to a, write them unfavorables. Okay. Now see guys, what happens. So if here your loop is ending, if you started from L and H and your loop is ending where your as I discussed already, your L will be here, H will be here. And I said that H can give you answer. Like 4 cross 4 was 16. But here do you think 3 cross 3 is 9? The 3 cross 3 is 14? No. So at the end, because this was your favorable zone, and if this number, if this k is a square, is perfect square, then its square root will be given by H. Its square root will be given by H. So finally what you have to do, you have to just check that if your H cross H is equals to k, then return true. If it is not, it will, this expression will become 0. H cross H, which is, let's say, 9. 9 is equals to 14. Nope, it will actually return you 0. Guys, are you getting this? So in this way you have to think. Now let's write this code for it directly. While L is less than equals to H, and here your L will be from 1, and you can keep H either from k directly, or you can keep k by 2. You can also keep k by 2. It will also reduce your search space. So in way it will reduce your complexity. Okay, now why I wrote k by 2? Think of it and write it down in comment. If you don't know, we'll discuss this later, or even in comments I'll try to solve it. But you can reduce this H from k to k by 2. Okay, now we calculate mid is equals to L plus H minus L by 2. And look guys, first thing, which is a favorable zone, favorable zone, lesser than equals to k. So what I say, if mid cross mid is lesser than equals to k, this is your favorable zone. And you know, when you are at favorable zone, what you can do, look, as soon as you think in this way, forget about this numbers, just be focused on this favorable and unfavorable zone. So if you are at favorable, where would you move? You cannot move to left, you have to move to right. So what you have to do, and who will move to right? L can move to right now. So L is equals to mid plus 1. Okay, else H is equals to mid minus 1. That's it. So this is your favorable zone, this is your unfavorable zone, that we like mark like this. And when this while loop terminates, what you have to do, return what? H cross H equals to k. Now listen, this H cross H equals to k, this will actually be true. This will evaluate true when H cross H is equals to k, and it will return automatically, it will return 1 or true. If it is not equal to, it will evaluate to false. This will evaluate to false, and it will return 0. So in this way, see, I have not changed the template of this binary search. Template remains as it is. Only thing is a little bit of tweak is required. Okay.